Hey guys, we are still in Unit 6, which is exponents and exponential functions. So today, what I want to look at is exponential functions and what the graphs look like. So my equation for an exponential function looks like this: a times b to the x power. And exponential functions are defined by the same equation, and it takes the form y equals a times b to the x. When b is greater than 1, the function is an exponential growth. And my graph is going to be increasing. When b is less than 1, the function is an exponential decay, and the graph is decreasing. When we look at these graphs, we're going to find something that is called an asymptote. An asymptote is a line that comes really close to a number, but does not touch. So we're going to look at what that looks like, because we haven't seen that in our math careers thus far. So those are some of the definitions that you need to know, and now we're going to graph them, and so you can see what it looks like. If you look at number 1, there's a lot of different things that I'm looking for in these graphs. So 1, I want to classify, is it exponential growth or decay? I want you to create a table of values and a graph, and then identify its key characteristics. So just looking at this, my b value, b is your base, right? It's what is being squared, or raised to the exponent. So this is 2, so that's greater than 1. So I know that I have a growth, okay? Now, it says create a table of values. So we absolutely can do that by hand. If I plugged in a -1, and I want to see a couple negative values, and I want to see a couple of positive values. So I want to see, like, let's say we had a -2. 2 to the -2, you'll remember, is 1/4. So it's basically 1/4. To the -1 power, it's 1/2. When x is 0, it's 1. When x is 1, 2 to the first power is 2. And when x is 2, 2 squared is 4. So I can do that by hand. That's not a problem. When I graph this, so if I have, here's -2, 1/4 is right here. When I have -1, 1/2 is right here. 0 and 1, 1 and 2, 2 and 4. So this is a little off. So you can kind of see the curve of that line. Now, again, if I have more points, the more I could fill this graph out. But you'll notice what happens is this line is going to come up, and then it's going to create an asymptote. It's going to come really close to 0, but it's never going to touch 0. So when I look at my domain, remember at the beginning of the year we said domain, how far to the left does it go? How far to the right does it go? So this will go to the left infinity and to the right infinity. So my domain is all real numbers. My range, how far down does it go? How far up does it go? So y is going to be greater than, not equal to, because it doesn't touch 0. It comes really close to 0 but never touches. So y is going to be greater than 0. My y-intercept, and I'm going to show you how to do this on the graphing calculators, but remember, definition of y-intercept is when your x value is 0. So here, I have identified my y-intercept as 1. And my asymptote, and I can even put 0, 1, that's my y-intercept. And my asymptote is y equals 0, because technically your asymptote is a line. So you need to still have the form of y equals 0. So this is the information that I'm looking at. In the next example, in example 2, I'm going to show you how to use a graphing calculator. All right, so let's take a look at 2. Right away, I know that my b value is less than 1, so I know that we're going to be looking at a decay. I'm going to make a table of values, and I always want my table of values to be a couple negatives, a couple positives. So I'm going to do -2, -1, 0, 1, and 2. Again, you can absolutely do these by hand, but I'm going to show you how to do it in the graphing calculator. So we turn our graph on. I'm going to go to the function screen where it says y equals, and watch how I type this. I don't know if you can tell, but I'm going to go y equals, I'm going to open parentheses, which is above the 8, and I'm going to type 1 divided by 4, close parentheses. You've got to close your parentheses or your graph will not read correctly. And then to get to the exponent, I'm going to do what's called a caret top, and it's right above the division sign. So I'm going to create that caret top, and then notice it pops up that exponent, so I'm going to write in there x, my variable x, which is that to the right of the green key. So I'm going to type that in there, and I don't know if you can see that, but that's what it looks like. And then I'm going to go to window. No, I'm not. I'm going to go to zoom. Sorry, I'm going to go to zoom, and I just want to see a standard window. So I'm going to type in 6 there, and that gives me a standard viewing window, and then I can see kind of what that graph is doing. Okay, so that lets me look at that. That lets me look at the graph, but I want to look at these table of values. I want the computer to work for me. So what I'm going to do is I'm going to go to second table, and then if I scroll up on the left, look, it brings me -2, and when x is -2, y is 16. When x is -1, y is 4. When x is 0, y is 1. When x is 1, I have 1/4. And then when x is 2, I have 0.06216. So I can graph these. So I get -2, and it takes me off the charts. -1 is going to go to 4. 0 is 1. 1 is 1/4. And notice as it gets 2, it's going to approach 0, but it's never going to really touch 0. So my line is looking like this. And notice it's decreasing. Okay? So my domain can still go all the way left, all the way right, which is all real numbers. My range is it's not going to touch 0. So it's going to be y is greater than 0. And my y-intercept, notice on my table I found it, is going to be 0, 1, and my asymptote is going to be y equals 0 because that's the line. Okay? All right. Let's look at we'll do number 3 and 5. Okay, so you should, if you, well, you can come and check it. If you don't have a graphing calculator at home, that's fine. But let's look at numbers 3 and 5. Okay, let me calibrate this real quick. All right. Okay, so here we go. I know my b value is greater than 1, so it's going to be a growth function. And I know I need to create a table of values, so I get my table ready. I'm going to go over here to my graphing calculator. I'm going to clear out what I had in Y1, and I'm going to type exactly what I see. I see 3. Don't forget that caret top, and that brings me to my exponent. I'm going to type in x. I'm going to move my cursor to the right 1, so it drops back down. If I didn't move that cursor to the right, it would still continue on with that exponent. So then I'm going to type in -1, and then I'm going to graph it so I can get an overall picture. And look, my asymptote's a little different. It's not approaching 0. It looks like it's approaching 1. So then I'm going to go read my table of values, and I'm going to scroll to where I can find when x is -2, y is -0.8889. When x is -1, it's -0.6667. When x is 0, y is 0. When x is 1, y is 2. When x is 2, y is 8. So I grabbed me a quick snapshot of that table, and now I can graph it. So -2, it's coming really, really close to -1, but it's not there. It's coming really, really close at -1, -0.6667, 0, 0, 1, 2, and then 2, and notice how much it increases. Okay, so when I graph this, it's coming really, really close to 1, but it's not approaching 1. It doesn't touch 1. So my domain is still going to be all real numbers because it goes all the way to the left, all the way to the right. My range now is going to be y is greater than 1. So my asymptote is y equals 1. And my y-intercept, I can pinpoint it on my table, is 0, 0. Okay? All right, let's look at number 5. Here we go. And I know that b is greater than 1, so I know it's going to be a growth. When I type it in, I'm going to go to y equals, clear out what I had. I'm going to open parentheses to get that fraction 1 divided by 4, and then I'm going to close it out. I'm going to type in multiplied by 2, and then I'm going to do my caret top to get that exponent, and x. And then I'm going to go back down so I can look at it. I'm going to graph it. And I can see that my asymptote is probably around that 0, so I'm going to pull up my table so I can find a table of values. Put these here. So when x is negative 2, y is 0.0625. When x is negative 1, y is 0.125. When x is 0, y is 0.25. When x is 1, y is 0.5. And when x is 2, y is 1. So when I graph that, negative 2, it's going to, x is negative 2, it's almost at 0 but not quite. Almost at 0 but not quite. When it's at 0, it's like a quarter. And when it's at 1, it's a half. And when it's at 2, it's at 1. And then it's just going to increase from there. So it's going to approach 0 as my asymptote. My domain is all real numbers. My range is going to be y is greater than 0. My y-intercept is located at 0.25. And my asymptote is going to be y equals 0. So that should give you a few examples of definition and what that graph looks like. If you have questions, come and see me.